Okay, so we're going to start on the next part of 2.6. At the end of the last video, we gave these functions to graph using vertical and horizontal shifting. So let's start with the first one. So essentially, I'm going to do this now in one step, or kind of directly. If we start off with the absolute value of x, well, essentially we shift. So there is, let's do it on this right-hand side here. So we're going to shift to the right by 4, and then down by 6. Okay. So what we get is, so the graph of f is here. This is f of x. And let's label one point. It's always good to have one reference point. We have to shift right by 4 and then down by 6. So our final graph of f tilde, so we go right to 4 here, and then down to -6, and then my graph would be like that. This would be the point 4, -6. Okay, so that's for the first part. For the second part here, it's a little bit, there's more going on. It's still the same idea, so we're replacing, let me do this in order. So we're starting with 1 over x, then we go to 1 over x plus 1, which is a shift to the left by 1 unit, and then we're subtracting 2, which is a shift down by 2 units. And hence, so what do we have? We have the following. So let's first draw the original 1 over x. Remember, this thing is, it has those asymptotes. Let me do those with a different color here. We have the horizontal asymptote, which is our x-axis, the vertical asymptote, which is our y-axis, and then there's the graph itself. Okay, so now we go back to the shifting process, and what we're going to do is, now you can think of shifting the asymptotes, right? If we shift left, so first we shift left and then shift down. So let me do this in one go again. So shifting left moves the vertical asymptote left to -1 here, because we're going to shift left by 1 unit. And notice that that corresponds to the denominator being 0. Remember, when the denominator is 0, that is always your vertical asymptote. I'll write that on the side here in just a second. And I'll color in the asymptotes also in just a second. But so one thing to note here is that the vertical asymptotes correspond to the denominator being 0. Okay, so we have done the shift left. Now we also have to shift down. Now when we shift down, the vertical asymptote is going to go, the horizontal asymptote is going to go down. So when we go down by 2, we're going to go 1, -2 here. That's going to be where our horizontal asymptote is. And now the graph stays essentially the same, but just shifted. So just to keep one, let's have 1 point as reference. In the original graph, 1 over x, we had 1, 1, which if we shift left by 1 unit, you would have, well, it would essentially, we're going to correspond to this point, right? Because We're going to shift left, which goes to the x point, then is going to be 0. If we go down by 2, it's subtracting 2 from the y coordinate, and 1 minus 2 is minus 1. So the original point 1, 1, when you shift it left 1 unit and down by 2, you get 0, negative 1. So this is the graph, and let me just to finish up here. Well, that was the 1 there. Colored that in. It's okay. Okay. So this is the graph of G tilde. Okay. So we're going to move to the next, next type of transformation, which is reflections. And this will be the last transformation that we learn. There's one more that's in the book, but I feel like that concept is best done in 142. So, and it's not very useful for polynomials. For reflections, what's going to happen? There's going to be two types of reflections. One is reflecting across the x-axis, and the second is reflecting across the y-axis. So we'll do one example of each. So for one here, let's take f of x, our base function is x squared, and let's take f tilde to be negative x squared. Okay, so these are two graphs that we might have already seen. We definitely have seen x squared. If we negate, and so notice this is the negative of the entire f of x. This can be rewritten as simply negative f of x, because if f of x is x squared, and our function is negative x squared, then we're negating f of x. If we plot some points here, so we still get, let's just plot a couple of points, 0, 0, 1, negative 1. Negative 1, if we plug in, we get negative 1 squared, and that equals negative 1 overall, because there's 3 negatives there. So what ends up happening is you simply take your parabola, and it points downwards instead of upwards. And so this is an example of reflecting across the x-axis. So this corresponds to whenever you start with a function, and the new function you have is simply the negative of the entire function that you started with. Okay. So that's an example of that. Let's do the second type where we're going to reflect across the y-axis. So let's take f of x to be the square root of x, and f tilde to be the square root of negative x. Now you might think, well, that doesn't even make sense because we can't take the square root of a negative number, but that wouldn't be entirely correct. So let's first find the domain of f tilde. Remember, the domain of f here is everything bigger than 0. X has to be bigger than 0 at least, or equal to 0. Whereas here, what do we need? Well, we need that the negative x has to be bigger than 0. And so, well, how do we get that? If you multiply by negative 1 on both sides, you get x less than or equal to 0. Because when you multiply by negative 1, the inequality switches. So it actually turns out if x itself is negative, or 0, then this is actually well defined, right? If x was negative 1, then if you take negative 1, you have the square root of positive 1, which is okay. So first off, the domain, there is a domain here. The question is now, what does this graph look like? Let's just plot in some points, where again f of f tilde is equal to the square root of negative x. So we have to start off with the negative values, -1, -4, and so on. Well, -0 is 0. The square root of that is 0. Here we get the square root of +1, which is 1. Here we get the square root of +4, which is 2. And so our graph here, let's draw the graphs of both. We already know the graph of f, which is this positive square root of x. It looks like this. And let's label one point here, say the point 1, 1. For f tilde, what does the graph look like? Well, we have 0, 0. We have -1, 1. We have 2, 3, and -4 right here, -4 and 2. So the graph is the same graph but flipped over. So these are reflections across the y-axis. So let me write that down. These are reflections of each other across the y-axis. Now, how do we write f tilde in terms of f of x? Well, the square root of negative x, what is the relationship to the square root of x? Well, if this is f tilde and this is f tilde of x is equal to f of negative x. And so what happens, what it turns out, is that in general, so the general theme here is if you start with f of x and the new function you have is f of negative x, then this transformation, the graph here, so this graph, the graph of this function is the graph of f of the original f of x reflected across the y-axis. Okay. So let me summarize all of the items in general that we have done so far, because there are 4 types of transformations that we have seen. So types of transformations, just so you have seen it all in one place, and then we'll do some examples where we mix a lot of these together. So the first was the vertical shift, and this is you start with the function f and you get a function plus or minus a number a. Okay, that moves it up or down. We're going to see them again. A is positive here. Then there's the horizontal shift, which is where you start with the function f, and the new function that you have is f of x plus and minus a. And remember the plus here, the plus sign corresponded to a shift to the left, and the minus sign corresponded to a shift to the right. Okay, just a reminder of that. The next one we saw was a reflection, which we just did. The reflections, of which there were 2 types. So let's say reflections across I'll just say about the x-axis. And that's where you start with f and you end up with the negative f of x. That's a reflection across the x-axis. And then there's the reflection across the y-axis. And that's where you start with f of x and you get f of negative x. So these are the 4 types of transformations that we'll focus on. And so what we're going to do now is we're going to do 1 or 2 examples, or at least one for sure, of a combination of a bunch of these. So let's graph, for example, let's call it g tilde of x being negative the square root of 1 minus x plus 3. And what we're going to do is, of course, you can get a sense of this without doing this stuff. You can directly plug in a few values. If you know the square root graph, you can do it without all of this necessary, available to you. But these are helpful at least. So let's do it with these. And what we're going to do is we're going to start off with a base function. We're going to start off with a base function g, and then get to g tilde by a series of steps. Okay, by a series of transformations. Again, you can, once you're comfortable, you can skip some of these steps, but in the beginning it may be good to do it step by step. So all this is based off of the square root function. So let's just start with the square root of x. So let's start, we want to eventually get to, let's first get what's in the square root itself, the 1 minus x. Since there's a minus x here, it's easier to keep x positive and just do, this is now a horizontal shift, right? If I just do this much, this is a horizontal shift left by 1, right? Left. Now, once I do that, now I can make x minus x. From here, the x became minus x, so this is a reflection across. You can look back to your table if you want, that if you replace x with minus x, it's a reflection across the y-axis. Okay. Then let's go ahead and negate the whole thing. If we start off with the function and you negate the entire function, I'm just going to interchange the order here. Negative x plus 1 is the same as 1 minus x. From here, I'm negating the entire original function here. So if this was the original, this is the negative of it. So this corresponds to having a function and then negating it. Hence, this is now a reflection across the x-axis. And then finally, I add 3. To get my final graph, which would vertically shift the previous graph up by 3. So this is kind of, if you want to do it stage by stage, this is how you would do it. So let's just do this stage by stage, because it makes sense then to just, since we're started this way, let's continue this path. This is the square root of x, and let's label the base point here. Say 0, 0. And it'd be good to draw some dividing markers here. Our next graph is shift left by 1. So say, okay, here's a negative 1. So I have the point negative 1, 0. That's my second graph. My third graph says reflect across the y-axis. So I say, okay, if I looked at the mirror image of that, and again, if mirroring is a little confusing, you can just look at that graph to plug in a couple of points just to check. So for example, negative 1, 0 would reflect to 1, 0. And instead of the graph pointing to the right, the graph would point to the left. So I have this. Now I reflect across the x-axis for the next one. So for the next one here, I reflect across the x-axis to get, so here's 1, 0. something like this. And then I shift up by 3. So finally, my final graph, this is the final graph. Is I take this and I go up by 3. So here's 1, and then 1, 2, and 3. 1, 3, and then I have something, and it's going to cross. It's not going to stay above the x-axis. It's going to keep going down. Let me just redraw that. Actually, looks a little misleading. So it's going to go down. It's going to cross the x-axis and keep going down forever. Okay. So that's pretty much the graph here. My graph is not to scale. I might have, the points may not be perfect here, but I just want the general feeling of the graph with at least one point plotted. Okay, so that's an example of a series of transformations that lead to your final graph. I'm going to leave you here with a couple of exercises to try. So let's try g tilde is equal to the absolute value of 1 minus x plus 2. And let's call this h tilde of x being negative x plus 2 squared minus 4. Okay, so try these out, and we will begin the next video with these guys.